So we're in your chemistry book in your last chapter, chapter 18, section 3, substituted hydrocarbons. And so now we're going to be talking about hydrocarbons, but they're going to be substituted by other types of atoms or molecules instead of just hydrogen, okay? Simple hydrocarbons consist of a carbon backbone chain, we know that, where several hydrogen atoms are attached by these covalent bonds. But these hydrogen atoms can be replaced by other types of atoms, and these are the atoms that we're talking about. So hydrocarbons that have one or more hydrogen atoms can be replaced by different atoms or functional groups, and all of these are called substitute hydrocarbons. And there's going to be quite a few different groups of substitute hydrocarbons. And so we're still hydrocarbons, but these are going to be totally different than as we went with the hydrocarbons with the fuels and the petroleum. Now we're going to get into other substances that use the hydrocarbon base, right? So the first one that we're going to talk about are alcohols. So we're the characteristics of alcohol too. So basically, alcohol replaces an hydrocarbon with what's called a hydroxyl group, OH. Whenever you have an OH, right away, man, that's a type of alcohol, right? OH, which is called hydroxide because it's oxygen and hydrogen. And so this hydroxyl group shouldn't be concerned with when we were doing the ion OH. Remember when we're talking about acids and bases, the hydroxide ion, we're not talking about that. We're going to be talking about the hydroxyl group, which means alcohol. So the names of alcohol, typically they'll have an OL ending. So you'll recognize them with the OL that they're a type in the category of alcohols. So the position of this functional group is indicated here, as you can see. Here's basically, you'll see where the hydrogen is. You're going to replace it by an OH. You're going to replace it by and make it into an alcohol. So let's see. We're going to go into the types, the examples, but due to the hydrogen bonding that occurs between water molecules and the hydroxyl function group, alcohols of low molecular mass are very soluble in water. That means alcohol will, dissolve in water. So when others of carbons won't, alcohol does dissolve in water. Alcohols that have more than 4 carbon atoms are essentially insoluble if they have more than 4. So basically saying alcohols usually will dissolve, but if they have more carbon they have, the less likely they're going to dissolve in alcohol. So let's go over to the examples of alcohol type hydrocarbons. And so we're going to talk first about methanol. Methanol is methic alcohol, which is either used to called as wood alcohol. And it's the thing about wood alcohol, if it was heated, heated without enough oxygen, it would produce carbon monoxide and hydrogen and carbon monoxide is extremely poisonous. So it's saying methanol can be very destructive if it isn't heated in combustion. You could actually causing death and carbon monoxide poison. But it also is extremely poisonous and taken in can cause blindness and such. So methanol is not, methyl alcohol in that way can be very detriment to your health, that's for sure. It's used in the solvent in varnishes and lacquers, so you don't want to breathe it so much in varnishes and lacquers. It's also used in the synthesis of formaldehyde. It's used in fuel for windshield washer fluids and fuels, and so methanol alcohol. Another type of alcohol. Oh, here's basically saying how you write it out. Basically, although the molecular formula of methanol is CH4O, it's usually written CH3OH to make sure it's an alcohol. So whenever you see that OH, that's methanol. Now we're going to talk about ethanol. Ethanol is grain alcohol, and it's used in the fermentation of corn or other grains, and the action of these enzymes. And it's usually found in yeast, chemically converting this starch into ethanol. So when you think of grain ethanol, what are you thinking of? You're thinking of alcoholic ethanol, the beginning of alcoholic beverages, right? So what are you thinking of? You're going to be thinking of alcohol that people drink, right? It's found in all alcoholic beverages. And they make it from the grains, basically as you're taking the grains, and converting them, to alcohol and fermentation process. So ethanol can be very toxic. It's a depressant of our central nervous system. Alcohol is. It's damaging to the liver. So it's also used in some flavorings and medicines, which are good, and it can be used as an antiseptic. And it's also added to gasoline. And so there's some good things about ethanol. But when you think of ethanol, that's the alcohol we think of, in alcoholic beverages. So another type of alcohol is the isopropyl alcohol. And this we find in rubbing alcohol. It's typically 70% isopropanol and 30% water. And so this type is basically 2-propanol, where's our C3H7. Remember, all of these are added to our chains of hydrocarbons, right? And the OH means that it's a type of alcohol. So that is isopropyl. It can be used as an antiseptic for and a synthesis of acetone in rubbing alcohol. And so this part says alcohols may have more than one hydroxyl group per molecule. So they have multiple additions, right? And with OH groups, there increases the solubility in water. So anyway, alcohols with 2 hydroxyl groups are called diols or glycols. And one important diol is ethylene glycol. And this is used as antifreeze in the coolant in the cars and truck radiators. And it's used at the synthesis of polyester fibers and films too. So, and it has a very syrupy and sweet smell, but it's very toxic and you shouldn't be ingesting it at all. So here's a picture of the products here. Here's a rubbing alcohol, antifreeze, and some other things, hairspray. These are all things that have our alcohols in it. So 2 groups of diols and glycols are ethyl glycol, and the other is onto glycerol. Have you heard of glycerol? Glycerol is a very sweet tasting liquid used in the manufacture of cellophane, drugs, cosmetics, and explosives, nitroglycerin. And it's also used as a sweetener in foods. So it's a very much variety, as for glycerol. So going on, another type would be sorbitol. So sorbitol, and here we have 6 hydroxyl groups, making it highly soluble in water. And despite its relatively high molecular weight, sorbitol is widely used as a moisturizer. Here's hand cream, right? Sorbitol. And also sorbitol is a reduced calorie sweetener, sorbitol. So another type of alcohol. Aromatic alcohols in which one or more OH groups are attached to a benzene ring are called phenols. And here's the OH at the end, C6H-OH, and it's used as an antiseptic for sore throat sprays and a disinfectant for plastics and fibers, and also uses plastic in manufacture of plastics and fibers and drugs. So those are the type of alcohols. Now let's go on to the next here. Wait here. Let's look at our chart here. So here we have methanol. We talked about here methanol. You can see the formula. Fuel, gasoline, antifreeze, formaldehyde, window show, ethanol, solvent, we went over, fuel, synthesis of alcoholic beverages and medications. Here's isopropanol, rubbing alcohol, solvent, antiseptic. You can see, so here's the forms. Here's what you're going to look like. Ethylene glycol, here we go. each one of these have a OH in it. So radiator antifreeze, cooling systems, polyester fibers, glycerol, manufacture of cellophane, drugs, cosmetic, sorbitol. Look how big sorbitol is here. All of these, moisturizer, sweet calorie foods, manufacturers of vitamins, textiles, toothpaste, cosmetics, and paper, sorbitol. And phenol here, see how this has this ring of delocalized, this is an aromatic, so it has the ring of delocalized electrons. It's antiseptic, disinfectant, manufacturers of plastics, fibers, and drugs. That's phenol. So that's just what I kind of went over already. So the next we're going to talk about is aldehydes. Aldehyde. So when you think of formaldehyde, right? So we'll talk about aldehydes and ketones, but we're going to talk about aldehydes first. Aldehydes have a molecular functional group that looks like this. So basically has a hydrogen and they have a double bond. And the aldehyde names end in Al, not Ol. So not Ol will be alcohol, but if it ends in an Al, it's going to be from the aldehyde group. And formaldehyde is one of the main. Formaldehyde is a gas at room temperature, and it's highly soluble in water and alcohol. It's used to preserve animal specimens, right? Formaldehyde. It's also a disinfectant and a germicide, and it's used in the manufacturing of plastics and adhesives and, rayon. Aldehydes are easily oxidized. Well, anyway, let's go on here and we'll talk more about aldehydes in the next before I get into talking about that. So we're going to talk, first of all, here's a chemical test for aldehyde, the Benedict's reagent. So you can put that in and it's going to turn red. The copper in it makes it turn red. And this is the Tollens reagent. And it's a positive silver mirror test, or whatever they call in the midst of a test for aldehydes. So 2 different tests. Here's a picture up here of aldehydes and ketones, but you can see the aldehyde has the double oxygen bond, right? And so, and acetone does too. So you're going to see the aldehyde looks like this, and the ketones look like just one bond. So you'll see the aldehydes have this group with the hydrogen at the end. Okay, so going on for acetaldehyde, and this is C2H4O4. And acetaldehyde is called ethanol. Make sure I don't say all. Al at the end. And it's used in manufacture of dyes, rubbers, acetone. Acetone, like acetone in nail polish remover, right? It's very toxic. We drank it, actually, but this basically is also used. Ethanol is also used to prevent headaches and hangovers. So even though it's toxic, they use that for that. So, and then aldehydes are fairly oxidized when heated, and that's that Benedict's reagent, which contains copper, and Tollens reagent silver. And so the Tollens reagent is used as the silver mirror test. And these reactions are the test for aldehyde right here. Those 2 tests to see if there's aldehyde in something. And so let's go on to ketones. So ketones basically are double bond. Let's see, that's acetone. Let's see where. Acetic acid, it's either double bond with an OH. Instead of an H, an OH. So ketones basically have this carbonyl with a carbon with the oxygen there. It looks like this with that double bond to oxygen, and they call them ketones. And so ketones, they're bonded to another, basically usually another, basically bonded to the oxygen in this whole thing. But they're also, it says, by contrast, an organic compound that contains carbonyl group bonded to any atom other than a hydrogen is a ketone. So it can be bonded to anything but a hydrogen, and they'll call it a ketone. And the most common ketone is acetone, and it's also called propanone, but it's acetone would be a ketone. See how ketone at the end? Acetone is that colorless liquid. Basically, going into that is considered the manufacture of aldehydes in the midst, turning it into a ketone, as we said before, but that's acetone. Acetone has a sweet odor and is used in the solvent for nail polish, plastics, paints, varnishes, and in cleaning metals and synthesizing many organic chemicals. Ketones, including acetone, are also produced in the body. Ketones in our body, if you're measuring ketones in your body, you're seeing that your fat is being metabolized, right? If you want to metabolize fat. But a lot of times people with diabetics, they don't metabolize carbohydrates well because of their pancreas, and they'll have a buildup of ketones in their body. So that's also with ketones. So ketone, here's acetone right here with that, and looking here we have acetic acid, lactic acid, citric acid. These we're going to talk about acids instead. I said ketones, but these are carboxylic acids. So let's go back here. Here's the ketone. Like I said, the double bond. It's kind of hard to know because these have double bonds too, but you notice that they have double bonds of the hydroxyl. They basically have the oxygen OH bonds on them. So that's the difference. So I kind of goofed that up for you. Hope you got that right. This is the carbonyl group that we're talking about, ketones. And so let's talk about the carboxyl acids and esters. So let's go back to here. Just remember, acetone looks like aldehydes. Kind of in the same group, aldehydes and ketones. So now we're going talking about carboxylic acids and esters. So carboxylic acid is the organic compounds that contain acidic function group, and they have the carboxyl acid. In contrast to many inorganic acids, carboxylic acids are generally weak acids and ionize only slightly in water to produce the hydronium acid, ion. The most familiar acidic acid is ethanoic acid. Although this compound is usually represented like this, acetic acid. When I see this, I always think, oh, it's acetic acid. But another way to write it is COOH. So maybe written as that. It's carbolic acid because of the OH. COOH. Placed at the end of the structure. It looks like this, CH3COOH. That's acetic acid. And it's a weak acid, and basically in the carboxyl group. So what about these carboxyl acids? They're found in many plant and animal products, and they have this strong pungent odors usually, except for citric acid. So that one has a pleasant smell. The rest of them are kind of pungent. Citrus acid is found in lemons and grapefruit and oranges, and the others are found in like spinach and rhubarb leaves and such. So we have a lot of different carboxyl acids. We have not only acetic acid, citric acid, oxalic acid, tartaric acid. Oxalic acid is in the leaves of rhubarbs, and tartaric acid is in grapes. Butyric acid is in rancid butter. Lactic acid is in milk. And there's another type of acid here. I'll look into it and find it, but it's in ant stings. So anyway, here's some carboxylic acid. Carboxylic acid. Just remember, here we go. Carboxylic acid. Acetic acid is vinegar. Lactic acid is sour milk. Lactic acid also is in your overused mussels. Citric acid is in fruit. So I hope I didn't get you confused, because I kind of went into ketones and was pointing here when I meant to be pointed up here for the ketones. A little bit different. Carboxylic acids and chemical reactions. So these, because they're acid, they can undergo ionization when they dissolved in water and they become ions, right? We saw that when we were studying about acids and bases. Since these acids are relatively weak, the equilibrium of the ionization lies to the left. So here we go. That means it always lies to the weaker side, so because the equation needs to be, when you have a chemical reaction occurring, it's always going to go to the weaker to balance it out, to make it in equilibrium. So it's always going to go to that side. And for the weaker acid, it always goes to the weaker. I think I told you that when we were studying acids and bases. So here we have a picture of that here, as you have, the acid there, the carboxylic acid, and you have it going towards, basically going stronger to the left there. And here you have producing what ion? That acid ion, the hydronium ion there. And just like it can be neutralized as bases, here we have a picture of it. We have the acid. This is the carboxylic acid, and this is the acid. It's neutralized by a base there, bringing in that base with that OH being the base, coming in, and it produces salt and then water. So remember, when an acid and a base come together, they always produce salt plus water. So those are the carboxyl groups. So now we're going to go through another type of group here. It's called esters. So what are esters in the midst of all this? So esters are a carboxyl group, and they react with alcohol in this point as a functional group. So they're bonded together here. So here we have a picture. Here's the group. So now we have the esters, organic, for the functional group right here, and they're bonded to something other than hydrogen. So not just alcohol. Some of them are bonded to alcohol and some are not, but they can't be bonded to hydrogen. They have another replace. This one has 2 oxygens actually. Esters are kind of cool. So another way you can describe it is COO instead of this figure, COO. And so ACOO is a group bonded as a carboxyl group there. So, okay, here we have a picture of it. Carboxyl acid, alcohol, catalyst, and then there's becomes the hydroxyl group of the carboxylic acid reacts with this hydroxyl group of alcohol to form water, and this is called esterification. So it's when it's reacting with alcohol. It says right here, carboxyl group is reacting with alcohol, and it's producing ester. Esterification means producing esters. So most esters are insoluble in water. Many esters have, very fruity odors and flavors, and they're used in perfumes. They're responsible for aromas, like the apple ester is methyl butyrate, pineapple ethyl butyrate, apricot pentyl butyrate, banana pentyl acetate, and orange octyl acetate flavorings. These are all esters. Other familiar esters are the oil of wintergreen, benzocaine anesthetic that's used in band-aids or ointments on band-aids and sunburns and such. And then there's also waxes. Esters can be like carnauba wax and beeswax. So waxes of esters are very long chain alcohols. So they combine with the alcohol. So here we have pictures of it. Let's see, do we have pictures of them? Thought we have pictures of them, I guess not. Oh, so anyway, here's a good picture of salicylic acid, as coming together in this COOH group. So the midst of that. So I didn't talk about this here. So basically, going back to the esterification, the opposite of esterification and making esterification is hydrolysis. It's the reversal, because you can take the esterification and reverse it back to water. And that's what that picture was here, coming back, reversing it back to water. So a specific esterification for the formation of ester salicylic acid, that's aspirin. So from salicylic acid and acetic acid, here we have a group. So we have salicylic acid here, and of course we have this group here that looks like benzene almost, but salicylic acid holding on to these, and we go into acetic acid, and so now we have aspirin. This is how you produce aspirin, by combining these two into this big group here. So I just wanted to show you how to make aspirin, I guess. So let's go on to the next one, is amines. And so this will be the last one on this video. Some very important organic compounds of biological significance. They contain nitrogen. So amines contain nitrogen, and they only have hydrogen, basically only have hydrogen, carbon, and nitrogen. So they only have hydrogen, carbon, and nitrogen. They're called amines. Now we get into amines, we're going to get into that in the next session because of the nitrogen there. Amines are very important. They can be considered a derivative of ammonia. Of course, ammonia has nitrogen, right? In which one or more hydrogen atoms have been replaced by the alkyl group here. So here we have ammonia here, nitrogen here. So as it coming in, you can see they'll have the nitrogen group, and the R means they're adding something to that group. So they can have another group added there, another group added there, but it has to be, amines always have nitrogen in it. So again, talking about amines, we have different kinds of amines, and it always has amine at the end, so you know where it comes from with nitrogen. They also are followed by amine. Again, you're going to have the ethyl group, the methyl group, all these groups followed by amine to tell that it is amine. Ethyl, methyl, amine. Ethyl, methyl, propamine, to type. See how they did that? Here's an amine, and then methyl group, ethyl group, propyl group, amine. They can be, these can be very complicated. Well, they're all kind of here, so amines. Okay, so like ammonia, amines act as a weak proton receptors and are very weak bases. So they're not acids, they're bases. And so they readily react with strong acids like hydrochloric acid, and they form salts. And so we have a picture of that, in the midst, how they would basically react bases and strong acids and become a salt. Do we have that? Let's see. It says, I thought we had a picture of it. I guess we don't. So, and they're soluble in water. For example, let's see. It says, as they readily react with strong acids like hydrochloric acid to form salts, they are much more water soluble than amine. For example, 0.5 grams of amine procaine is soluble in 100 grams of water. So when converted. Anyway, here we have some pictures. Amines that occur naturally are known as alkaloids. So some alkaloids, some famous alkaloids are nicotine, so morphine, caffeine. Those are just three of over 20,000 or 2,500 amines, and they're classified as alkaloids. And among these alkaloids contain nitrogen, of course, and the carbon rings. So they're known as heterocyclic compounds. Hetero means different. And some amines are based on compounds of nutrients like vitamins. And so their vitamins can be amines too. So we're looking at a lot of different areas. Here's some pictures of amines. Here's caffeine, found in coffee beans, tea beans, nuts, and everything. So this is amine because it has a nitrogens. It has these nitrogens in it, and you can see how everything's attached. This formula is caffeine. It's methoxyamine. I can't pronounce that one. But anyway, here we have antihistamine, a sedative, is diphenylhydramine. So here we have that. It has the nitrogen in it. It's amine. And it's used as decongestants and also in itch sprays and motion sickness and medicines and sleeping aid. Here's another amine, adrenaline. Epinephrine is an amine. It's a hormone produced by the adrenal gland that prepares the body for emergency action. Adrenaline is amine. Another amine is morphine, found in the opium poppy, used medically for relief of severe pain. It can be addictive. Morphine, another nitrogen amine. Nicotine here, another 2 nitrogen here, found in tobacco, short-term stimulant, small doses, but can be toxic in larger doses. So nicotine. So these are amines. So let's see, we're going to go into the amides, and then I'm going to, let's see. Yeah, let's just go over, we went through the alcohols, amides. So amides, it's substitute with an OH, which is the alcohol OH kind of group. You'll find the results. It will produce, contains, let me see, let me read this for you to describe it, because I'm not describing it right. If an amine group is substituted for the OH group of carboxylic acid, the amide functional group results. Thus, in contrast to the amine functional group, which contains only carbon, hydrogen, and nitrogen, the amide functional group also contains oxygen. That's what I thought. So basically, you're adding oxygen to these amines. So it also has oxygen in it. Hydrogen atoms or groups are attached to the nitrogen atom. To complete, it's required for 3 bonds. And then the amides are a very important class of compounds for biology standpoint. Amide, samples of amides often end in amide, A-M-I-D. But the more complex ones have different names. You can't hardly tell that it's an amide. When you go on there, we're going to get into next on the biological hydrocarbons. And a lot of these are going to be in this category of amides. So let's see, let's go ahead and finish. So amides, the pain reliever and fever reducer, acetaminophen, which is Tylenol, is a amide. Several antibiotics, such as penicillin, is amide. So many sedatives are in the amide group. Phenobarbital and diazepam, they're sedatives. They're also for anticonvulsions, and they are in the amide group. And so the amide functional group undergoes hydrolysis to produce carboxyl acid and amine. Anyway, here's a picture of it, how it can go through. As for, remember the amides, they're going to have nitrogen, and on the midst of this nitrogen, they're going to have oxygen too. That's the difference, is this oxygen. The oxygen makes it amide. Amide would be oxygen. And this type of a reaction here they're talking about is in digestion of proteins. So here's some biologically important amides. Here's acetaminophen. You know, that's pills, acetaminophen, Tylenol, phenobarbital. You can see that. The difference is it has oxygen in it. See how oxygen are in it. Oxygen and nitrogen. Amides also here. Here we have penicillin. Here we have diazepam, another type of medication. So amides have a lot to do with different drugs and medications, right? They have the oxygen and the nitrogen, both. That's the difference between an amine and amide. So there are other substitute hydrocarbons you can imagine. And a lot of these other ones we think of basically haloalkanes, alkyl halides. So here we have. So we have epoxy groups, and you can see that picture, and thiols, which are substitute hydrocarbons. It's a limited variety. So here's some pictures. We have purofluorocarbons onto here, epoxides, thiols. You go on and on. There's a lot of different types. So you can have a lot of different types of substituted hydrocarbons. So that's the end of this group.